Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And in this short video, well, it might not be that short, yeah, okay. We're going to try to find the inverse of a particular matrix using what's known as Gauss-Jordan Elimination. Okay. The matrix that we're going to concentrate on is this matrix here, A. Okay. You can see that its dimensions are it's a 3 by 3 matrix in the sense that there are three rows and there are three columns in this particular matrix. Okay, and what we want to do is we want to find this special matrix, which we're going to symbolize as A inverse. Okay, where this particular matrix is going to have some special properties. The special properties are going to be that A times A inverse, the product of the original matrix with this matrix that we're going to find, okay, should give us the identity matrix. Okay, and actually, irrespective of which way we do the product, we should get the identity matrix. Okay, so A inverse will commute with A, and in all cases will give us the identity matrix. So we want to try to find this particular matrix. So step one, what we're going to do is we're going to create the augmented matrix. Okay, so we're going to create the augmented, okay, matrix. Okay, that's where we're going to take our original matrix and we're going to augment it with the identity matrix. So what do? We take the original matrix, okay, which is 8 minus 3 minus 5 0 1 2 4 minus 7 6. Okay, and what we're going to do is we're going to augment it with the identity matrix 1 0 0 0 1 0 0 0 1. Okay, so this is our identity matrix here. And what we're going to try to do is we're going to try to do what's known as elementary row operations. Okay, and we're going to try to convert this particular matrix here, okay, into the identity matrix. And by an elementary row operation, I mean any operation where we I suppose we multiply a row by a particular value, okay, or divide a row by a particular value, or where we add and subtract rows with each other. Okay? But I mean, the first thing that we do after we construct the augmented matrix, the first thing that we do is we always try to create our first pivot point. Okay, we look at the first row, we look at its first entry, and we try to convert that particular entry into a 1. So how would I convert an 8 into a 1? Now don't forget, we can only multiply or divide by specific values. There are elementary row operations. So how I convert an 8 to a 1 is by dividing by an 8. So if I divide this entry by an 8, I need to divide every single entry along this row by an 8. So don't forget, this is row 1, this is row 2, and this is row 3. Okay? So what I'm going to do is I'm going to update row 1 by dividing across by 8. And the way I'm going to write that down is I'm going to say row 1 is going to become row 1, okay, multiplied by 1/8. Yeah, okay, so it's going to be multiplied by an 8, and that's how I'm going to update row 1. So let's do that particular operation. So I'm going to reproduce my matrix. So 8 gets divided by an 8, or 8 multiplied by an 8 gives us 1. Minus 3 multiplied by an 8 gives us minus 3/8. Minus 5 multiplied by an 8 gives us minus 5/8. Okay. Continuing across, 1 multiplied by 1/8. Okay, that's the value here for our 1. Okay, 1 multiplied by 1/8 gives us 1/8. 0 times 1/8 gives us 0. 0 times 1/8 gives us 0. Okay, so that was the update operation we have performed here for the first row. And we didn't do any operation on row 2 or row 3, so they remain the same. So that remains as 0, 1, 2, 0, 1, 0. 4, minus 7, 6, 0, 0, 1. Okay. So now that we've converted the first pivot point, okay, that's the first entry on the first row, okay, into a 1, we proceed to through elementary row operations to convert every entry underneath this particular pivot point to a 0. Okay, so don't forget, once again, this is row 1, row 2, and row 3. Now, there's nothing that we need to do at row 2 at this particular point here because it is currently a 0. But what we need to do is we need to convert this 4 into a 0. Now, all I can do is multiply by specific values, okay, or divide by specific values, but I can't multiply across by 0. Let's keep that in mind, yeah. But what I can also do is I can add multiples of other rows to this particular row. And hopefully you can see that if I add minus 4 times row 1 to this particular row here, this would be minus 4, this would be a plus 4, which would give us a 0. So what I'm going to say is this, I'm going to say that row 3, okay, that row 3 is going to become row 3's old value minus 4 times row 1's current value. And what happens is this, is that our matrix, and don't forget I'm not doing any operation on row 1 or row 2, so the matrix becomes 1 minus 3/8 minus 5/8, okay, 1/8, 0, 0, okay. We're not doing any operation on row 2, so this is a 0, a 1, a 2, 0, a 1, and a 0. But we are updating row 3.